Okay, today we're going to do 4.9, but first I have this little comic strip for you, Math Chivalry. You guys see it? This is like PEMDAS. He's letting these all go through the door first. Pretty funny. Okay. Okay, 4.9a, because I'm actually going to split up scientific notation into two parts, 4.9a and 4.9b, because there's just a lot to cover. Okay, so scientific notation is when you take numbers to the power of 10. The reason we use scientific notation is when we have really big numbers or really small numbers. We don't want to write them all out. So it's kind of just shorthand for math people, okay, so, or scientists. Okay, so there's always to the power of 10, okay, you're not going to take anything to the power of anything else. So, what was I going to write? Okay, so the key to scientific notation, I'm going to change my color real quick, is that the first number must be between, this is the key, must be between 1 and 10. Okay, so it cannot be 0.5 and it cannot be 10.5. It has to be between 1 and 10, which I'll show you here in a little bit. Okay, so an example of scientific notation would be 8.9 times 10 to the fifth. So this right here is always 10. Always in scientific notation. Okay, the base is always 10. You notice how 8.9 is between 1 and 10. It's less than 10, it's bigger than 1. How you would write this in standard form, okay, which I'll show you here in a little bit, but you're going to take this decimal and move it to the right 5 places, okay? So it's going to end up 89, 1, 2, 3. So if we did 1, 2, 3, 4, we have one more 0. You just add zeros, okay? So if we started with a decimal right here, like we did, then we move it 1, 2, 3, 4, 5. It would be right here. So your answer would be 890,000. This would be what it looks like in standard form, okay? So let's do some examples, all right? Write in scientific notation. So these are all given to us in standard form. So scientific notation, okay, remember it's going to be a number times 10 to another number. So we have our decimal here. Remember, whenever we have a whole number, the decimal's at the end. We go over 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8. And how did I know to stop between the 5 and the 4? Why didn't I stop between this 4 and 5? It's because 5.4, and you have to write all the numbers, 5.45. You write all the numbers that are not 0 over here. If this was 54577, you'd put 5.477. You write them all that don't have zeros. Okay? So we moved it over 8 places, so that's why the 8 is there. Okay, we went from bigger, okay, we had a big number, so our number is positive up here. Okay, so again, we start here on number 2, we move over 1, 2, 3, 4, 5. We stop at the 7.23 times 10, and how many did we say? 1, 2, 3, 4, 5 times 10 to the 5th. Okay. Now this one you notice, now these numbers are really big, or they're fairly big numbers. These numbers are small numbers, so we're going to go the other way. Okay, so we're going to go, we still want to get it between 1 and 10, so it needs to be between that 2 and 1. So 1, 2, 3, 4. So 2.1 times 10, but we're going to make this to the negative 4th. Okay. When you go the other way, it has to be negative. Think if you have a small number, it's going to be negative. If we go this way, 1, 2, 3, 4, 5, 6, 7, 8. 9, because we have to make that a 5 times 10 to the negative 9. There does not have to be a decimal there. It can just be a whole number. Okay, but that 5, you can't make it 0.5 because that's not between 1 and 10. Okay, let me see here. Okay, so now let's do it the other way. Okay, let's move it from scientific into standard. You have to know those vocab, scientific to standard. So now this is 8.9 times 10 to the 4th. So since this is positive right here, we know our number is going to be big. It's going to get bigger. Okay, so we have 8.9, and we're just going to move it to the right. 1, 2, 3, 4. And we fill those in with zeros. So it's going to be 8, 9, 0, 0, 0. Yes, you need to rewrite it. I don't want to have to try to look through all of your loops. Okay, so 89,000. Now this one has a negative 6, so that means the number is going to be smaller. Okay, so we have, so you might want to scoot over a little bit. 2.71, we have to move it over 6. 1, 2, 3, 4, 5, 6. That's where our decimal is going to go. Okay, so it ends up being 0.12345 Yes, you have to write all those. Okay, so that would be your answer there. Now here we go back. This is positive. Okay, so we're going to make it bigger. We're going to move it to the right 7. 1, 2, 3, 4, 5, 6, 7. So that's going to be 3, 2, 1, 1, 2, 3, 4, 5 zeros. Whoop. 32,100,000. Okay, this one, you look, it's negative, so we're going to move it to the left. Okay, so I'm going to move it over a little bit. 5.9, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it looks like we have 7, 1, 2, 3, 4, 5, 6, 7, 5, 9. Okay, and remember this over here is what we're looking for. Okay, so that is a really small number. Okay, it's really close to 0, but not quite. It's between 0 and 1. Okay, moving on. Now these get a little bit more difficult. You really got to think on these. Okay, so these look like they're in scientific, but what do you notice about them? Why would I say those are not in scientific? Okay, think about it for a minute. Why would I say those are not in scientific? Well, our very first rule was it had to be between 1 and 10. 0.37 is not between 1 and 10. Okay, so what you have to do is you have to make 0.37 into scientific notation like we just did. Okay, so we move it over. So that becomes 3.7 times 10 to the negative 1, because we went to the right, so that's times negative 1. But then we also have this one here. So now you're going to use your exponent rule, times 10 to the 10th. So remember our exponent rule, when we multiply something with the same base, we add our exponents. So we're going to end up with 3.7 times 10 to the 9th, because it's negative 1 plus 10. Okay, these can be really confusing, so just take your time and just take your time. Sorry, my phone, I just got a text message. Okay, so 453.1 times 10 to the 8th. Again, this is not in scientific notation yet, so we have to move it over. So let's write it right here. 453.1. We got to move it 1, 2. So this becomes 4.531 times 10 squared, because we moved it twice. And then we have to go back and add that 10 to the 8th. Okay. So that is going to give us 4.531 times 10 to the 10th. Whoops, I kind of ran off the page, but that's 10 to the 10th. Okay? Okay, let's do a few more. I know this is a little confusing, but let's just hang in there, okay? So this next one is 16. Remember the decimal's right here when it's a whole number, so we got to move it. So 16 written in scientific notation, you move it once. So 1.6 times 10 to the 1, and then times 10 to the 5th because of this right here. Okay, so it becomes 1.6 times 10 to the 6, because remember, we're just multiplying these all together, so we add our exponents. On this one, 7, I wonder if I meant to put a decimal there. No, 7243, so 7243, if we're going to just write this number in scientific notation, 1, 2, 3, and we move it 3 places, so it's really 7.243 times 10 cubed, and then you have to go back and add on the 10 to the 12th, so we're going to add our exponents there. So 7.243 times 10 to the 15.